Hey, we're back again, and it's Mr. Lum, and we're going to do some more electrochemistry, and we're going to balance another redox reaction, but this time instead of balancing it in a acidic solution, we're going to see about balancing it in a basic solution. Okay, so it's very similar to the last video where we balanced it in an acidic solution with a few small changes, and I wrote the steps right here. And for some reason it should be 1, 2, and I think this one should be 3. Okay. Anyways, let's balance our solution. Anyways, step 1 for balancing this particular redox equation in a basic solution is balance the majors, okay, which we're quite familiar with. So I'm going to rewrite this equation right here, and as this. AS4, make my pen a little smaller, AS4 plus NaOCl plus water makes ASO4 3 minus plus NaCl. Okay, so we balance. We haven't balanced the majors yet. So what we're going to do is balance the majors. We see Na is a major here, and Cl is a major. There's 1 on this side, 1 on this side, and 1 and 1. So NaCl is already balanced. Oxygen and hydrogen are not majors. Okay, so we don't have to worry about balancing them. Now As. We have 1 on this side and we have 4 on this side, so we're going to times this side by 4. Okay, so the majors are now balanced. Check. Now we're going to find the change in oxidation numbers. So let's take a major like this one, AS4, one that we just finished balancing. And let's see how does it change when you go from here to here. So this has an oxidation number of 0. Okay, and this has an oxidation number of, well, let's see, AS4. I'm going to write AS4 over here. ASO4 3 minus. ASO4 3 minus. So this is minus 2, oxygen is minus 2, times by 4 is minus 8, equals minus 3, and this is going to be added to this one right here. Okay, so this is going to be, it looks like AS is going to be 5. Okay, and since there are 4 of these, okay, it's 5 times by 4. So this is going from 0 to 5, but there's 4 of them, so we times it by 4. So it's so there's 0, and it's going to plus 20. Okay, so we can write that right here. It's going from 0 on this side, and then when it changes, it goes to 4 times plus 5, okay, which is 20, and so the change is change in oxidation number. It increases by 20. Okay. So an increase, that means it's being oxidized. So that means this molecule right here, as it changes from reactants and goes to products, it's losing 20 electrons. Well, the oxidation number is changing by 20. Okay. Now what we're going to take is, we'll take a look at Cl right here. And we could take a look at Na or Cl, but we'll take a look at Cl. Now, this is an interesting one. We have a very interesting compound right here. If Na is going to be plus 1, Okay, the total charge of this is 0. O right here is typically -2. Okay, and Cl right here is, well, in order to make this 0, Cl has to be +1. Okay. So, when this changes, it's going from +1, and this is +1 to -1. Okay, it is decreasing. The change in oxidation number is going from +1 to -1, and there's only one of these and one of these, so you don't have to times by anything. But the change in oxidation number, from going from +1 to -1, change in oxidation number is -2. Okay, remember, if one is increasing, the other should be decreasing. So now what we need to do is we need to balance the oxidation numbers. Okay, so what we should be doing is, if this is going up by 20 and this is decreasing by 2, we should be timesing this reaction, this second part, by 10. So then the change in oxidation number would also be -20, and this one would be +20. So what we want to do is we want to put a 10 right here, and we want to put a 10 right here. Okay? Now so that's just exactly the same as what we did before in the acidic one. Now what we're going to do is, this is a change. We're going to add OH minus in order to balance the charge. Okay, so normally you'd add something like electrons to balance the charge, or something along those lines, but we're going to add OH minus to balance the charge. We're not adding OH to balance the oxygens or the hydrogens. We're adding OH to balance the charge. So let's rewrite the reaction here so we can see it more clearly without all this stuff around it. So we have, again, AS4 plus, and we change this to 10 NaOCl plus H2O makes 4 ASO4 minus and 10 NaCl. So what we're going to take a look at is, we're going to look at the total charge on this side. So this one has a total charge of 0, total charge of 0, total charge of 0. On the reactant side, total charge is 0. Okay. Now these 10 NaCl's, they have a total charge of 0 as well. Now we have a -3 here. So we have a -3, but we also have 4 of these. So 4 times -3. This is on our product side. We have a total charge of -12, and on the reactant side we have a total charge of 0. So what we're going to do is, we're going to add OH to the reactants in order to make the charge equal. Okay, so if we add 1 OH minus, now the total charge here is not 0, it's -1. Okay, so 0, 0, 0, and we have a -1 charge, and this is -12. So they're still not equal. So what we're going to do is, we're going to times the OH right here by 12. We have 12 OH minuses. So now the total charge on the reactant side is -12, and the total charge on the product side is -12. And what we did is, we added OH minus. Okay. Now what we're going to do is, we're going to add H2O to balance the hydrogen. Normally we add H2O to balance the oxygen, but for this step, we're going to balance H2O to balance the hydrogen. Okay, so a little bit different. So again, we're adding H2O to balance the hydrogen. So let's get to work here. So I'm going to rewrite the equation one more time. 12 OH minus plus AS4 plus 10 NaOCl plus H2O. We have one H2O already. And we then we're going to put 4ASO4 3 minus and 10 NaCl. Okay. Now we want to balance the hydrogen. So how many hydrogens on the product side? 0 hydrogens. How many hydrogens on the reactant side? Well, we have 1, 2, plus 12. So that's 14. Okay, so what we're going to do is we'll add 14. And so if we add 7 water, 7 times H right here, H2, so that's 14 hydrogen. So we're going to add 7 water, 7 H2O. And then, well, we see there's an H2O here and now an H2O here, so this one can cancel with one of these ones, leaving a 6. So make it all nice and pretty. I'll rewrite it one more time, and we have 12 OH. Oh God, that is not pretty. 12 OH minuses plus AS4 plus 10 NaOCl plus, now we got rid of our H2O, so we don't need a plus right here, so we're just going to write a big arrow. And so that's our reactants. 4ASO4 plus 10 NaCl plus 6 water. Okay, and so what we should find is, if we want to check our answers, we can check by seeing are the majors balanced, and we have 4 here and 4 here. We have 10 Na here, 10 Na, 10 Cl, 10 Cl. Good. So the majors are balanced. Are the oxygens balanced? We have 12 right here plus another 10 right here. So that's 22 oxygens. And then we have 4 times 4, that's 16. Okay, plus another 6, that's 22 oxygens as well. And now for hydrogens, we have 12 hydrogens on this side, and we have 6 times 2, it's 12 hydrogens on this side. Good, so our hydrogen balance. And finally, the last thing, just to make sure we have the right answer, we're going to check if our charge is balanced. Total charge on this side is minus 12. 4 times minus 3 is also minus 12, so the charge is also balanced. So this is our final answer. Okay?